Why do we require data structures and algorithms? When the applications are getting complex and the data to be processed is huge in number, there are three common problems that applications face. I'll repeat. When data is huge in number and the applications to be used or developed is complex in nature, there are three common problems that application development face. One is data searching. When the quantity of the data increases in exponential form, then the searching process really slows down. It will become slower and slower as the quantity of data increases. Another one is processing speed also decreases when data to be processed is very huge in number. Another problem is when we have multiple requests, because in complicated applications many users will be accessing data simultaneously, like in web server. Even a fast server fails while searching the data. So these are the three common problems that application face. Data search when quantity of the data is large in number, reduction in processor speed as the data quantity increase, then multiple requests from many users to be attended at the same time also creates problem. To solve this problem, we use data structures. We should structure the data in some order so that the retrieval or accessing should be used in an optimized way. Data can be organized in a data structure in such a way that all items may not be required to be searched. If we are having lakhs of records, it is not necessary that all the records are to be searched for every search request. So according to the requirement, we should use different data structures for attending to the data requests. Now let us see some applications of data structures and algorithms. Algorithm is a step-by-step procedure. The steps required for solving a problem is called as algorithm, and we have seen that we can have different algorithms for solving the same problem, and it depends on the machine and on the requirement, etc., which algorithm has to be used at a particular instance. So we have some measuring techniques and tools for selecting an algorithm. Algorithms are generally treated as the steps that are language independent. Algorithm must be implemented in more than one programming language. We will be selecting the language only after selecting which algorithm is to be performed. From the data structure point of view, following are the important categories of algorithms. We can categorize the algorithms into different applications. One is search, algorithm for searching item in a data structure. Another one is arranging the order of data, which is called as sorting. There are some algorithms to arrange data in a particular order. Another is insertion, algorithm to expand the database. that already we have. Next one is updation algorithm, to change some data as changes require. As time progresses, we may have to change the available data, which is called as updation. Then removal of unwanted data. So these are the main processes or algorithms or steps to be attended while designing an algorithm. One is searching, another is sorting, which is arrangement of data, then addition of new data, updation on the existing data, then removal of unwanted data. So data structure can be viewed in different ways. It can be defined as an arrangement of data in computer's memory. That arrangement makes our retrieval or accessing easy. It's a software artifact, means it's a technique for arranging the data to be stored or organizing the data so that accessing becomes easy or simple. Then it is a structured program used to store ordered data so that various operations can be performed easily. So we can see data structure in different angles. For example, if we have an employee's data like name, salary, and this data will be of different types, we can organize this data as a record like employee record and collect and store employee's record in a file or database as a data structure like some collection of values. And we can assign some relation among these data so that the collection can be based on that relation, and it can be used for storing these values in a better way. It can be also treated as a specialized format for organizing and storing data that can be accessed within appropriate ways. And all these things you might have heard or learned in previous classes. You may be knowing the importance of data structure also. It goes like this. Data structure is important because it's used in almost every program or software system. Because almost all the programs or applications may require data to be retrieved, accessed, or modified. For those things, we use the structuring of data. It can be used for writing efficient code, structures the code and solves the problem. Data can be maintained more easily when it is structured. All these things are well known to us. And there are some examples connected with online shopping and so they will be using different types of data structures for organizing and maintaining the data available with them. And we have different data types like this: integer for representing number, float for representing decimal valued numbers, character or fractional numbers, character for using single characters, boolean for logical values either true or false. Likewise, we can have different data types. All the above things are two simple facts about data structure, and let us see some types of data structures. It can be divided broadly into two. One is primitive data structure and the other one is non-primitive data structures. Primitive means we have seen that the data type can be integer, float, character, boolean. These things are categorized into primitive data structure. From these data types, we can generate other data types, which is known as non-primitive data structure. Again, we can divide non-primitive data structure into two: linear data structure and non-linear data structure. We have further classification for linear data structures as arrays, linked list, stack, queue, etc. And non-linear is being divided into trees and graphs. So this will be a general picture of different data structure most commonly used. Let us see them one by one. Primitive data type are the data types available in most of the programming languages. We have seen those primary data types in almost all the languages with which we declare the data to be used in a program. So they are called as primitive data types. They are used for representing single values. Suppose we say int a, that a is being used for storing a single value at a time. It can store another value in a different time, replacing the old value. So primitive data types are used for storing a single value at a time. It's a basic data type available in most of the programming language. Basic means it can be used for forming another secondary type of data. So primitive data types are the data types available with most programming languages, and they represent single values. They are also available as basic data types in most of the programming languages. Now the non-primitive data type are derived from the above primary primitive data types. Primitive data types are grouped in some way or organized into a different form, which form the non-primitive data type. They are used to store group of values as against the single value in primitive data type. It's obvious that when we combine primitive data types to form another group, we can store more values in non-primitive data type. It can be divided into two, as we have seen, linear and non-linear. A linear data structure traverses the data elements sequentially. We have a definite order of elements stored in them. Like one element will be coming after the another element. We can say definitely that this is before this or this is after this. So that is known as linear data structure. In linear data structure, only one data element can directly be reached. When we travel from one element to the other, we have only the next element in queue. So if we say that A, B, C, from A we cannot go to C without going through B. So from one element we can reach only to the next element in a linear data structure. And some of the linear data structures are arrays, linked lists, stacks and queues.